Well, first of all, I want to thank Dr. Siddiqui for extending to me the courtesy of referring to me as a scientist. So, what I'd like to discuss, first of all, is really, I think, the appropriate reason for putting the California Telehealth Network proposal at the front of these discussions. I'll just reiterate everything that the previous speakers have said. One of the principal goals of this colloquium, and I'm sure subsequent colloquia, would be to elicit discussion and subsequent collaboration among researchers that we know and would hope would lead to the expansion of our knowledge, clinical knowledge, and so forth. But most particularly as well, we hope that this leads to new services, new modalities, and new products that can then improve clinical care. And the ultimate step in that process, actually, is always to take what we've developed in the laboratory, take it out of the laboratory, and put it into the real clinical world. And those of us who have experienced that process have probably also experienced the humbling nature of that process. And nowhere is that truer than in the rural communities. So in addition to all the other complexities and problematic issues related to taking a prototype environment into a clinical area, you have the additional complications of the logical problems, the logistical problems, as well as all of the networking issues and so forth related to having good communications in those areas. And that's why I think that there is such an opportunity with the California Telehealth Network to establish what I like to think of literally as a statewide laboratory where we are going to have the opportunity to have a very high quality, ubiquitous, interoperable network capability that extends literally throughout the entire state. And so it's going to open up diverse opportunities for us to develop research collaborations with remote colleagues, but also, I think most importantly, to test new technologies in an entirely new way. And so what I'd like to do, first of all, is to just very, very briefly give you an overview of the California Telehealth Network. I'll touch sort of at a 50,000-foot view on the technical design that will be implemented. And then since there are going to be so many good presentations today that relate to clinical applications, I thought it would also be useful for me to take a couple minutes and talk about some network-oriented research opportunities that would be available for the computer scientists and the network scientists that may also want to participate in a project such as this. The FCC pilot project was funded to develop a network infrastructure across the entire state of California. During the 3-year period, we intend to extend broadband capability connections to 300+ rural healthcare sites throughout the state. And you can see from this map, now you're looking at that and saying, well, there aren't 300 dots on that map, but each of those represents a nidus where there would be multiple facilities that would be connected. But nonetheless, there is really no area within the state of California that we don't intend to connect up through this network. We will be addressing the technical and cost constraints that have heretofore really prevented us from doing this sort of thing. And, you know, I can use the hackneyed term, facilitate the use of state-of-the-art telehealth services that we will be employing because the broadband connection will support current and we believe intermediate, perhaps not long-term telemedicine needs, continuing medical education, and then also, most importantly, another very, very important area for development nationally is the integration of diverse medical records into a unified health record. And some of you are aware of initiatives like RIO and so forth, Regional Health Information Organizations. What a wonderful platform this network will serve in order to use to have a distributed testbed to integrate that kind of environment. This is a very, very high-level view of the California Telehealth Network design as proposed and approved by the FCC. There's really two sides to this diagram. There's the right-hand side that includes a hub infrastructure that's interconnected through an MPLS-routed hub matrix that will interconnect all these rural sites into what we like to refer to as virtual regional hubs. And I'll go into a little bit more detail about why we are considering these virtualized hubs in the next slide. That whole infrastructure, that whole hub infrastructure, will then interconnect with a backbone network that will provide access to the various UC medical centers and campuses, as well as to Internet 2 and to National Lambda Rail. And in fact, the FCC order specifically addressed the issue of interconnecting to national lambda rail. So that's an important part of the design criteria. This goes into a little more detail, what we really refer to as regional hub. One of the most problematic issues in developing rural infrastructure is finding sites for physical co-location of circuits. And so the design using MPLS as the backbone routing modality really virtually eliminates the need to develop physical regional hubs. There would be individual T1 level connections, and I would say that the minimum connection to each regional site will be a T1 connection. And those would be integrated into a local central office, either through a local exchange carrier or a competitive local exchange carrier. Those would be aggregated into a virtual regional hub matrix, and then that matrix is connected up to the backbone using some high-performance networking capability in an area like Sacramento, and certainly there'll be another one probably in Southern California. So the net effect of this is that every single participant in the California Telehealth Network will get a minimum of a T1 connection. And I know for those of us who are so privileged to be in an institution like this or in an urban area where you have op-demand service available and so forth, trust me when I say that developing a ubiquitous T1 level connection, it will be a huge advancement in rural telehealth. In fact, there are still areas in Northern California where it is not possible to even install T1 connections because of backhaul congestion from the local exchange carriers. So this will be a tremendous advance in terms of network connectivity. This network will provide all the necessary security and that is required through governmental regulation. And I'll talk about that in a minute. And so basically this will serve as a foundation network upon which we can not only deliver telehealth information and provide telehealth services, but also serve as a wonderful platform to roll out prospective new technologies in a rural environment. And what I'd like to talk about now very briefly is just some of the areas where I see particular benefit in terms of developing research opportunities. One would be, it is extremely important that we address the issue of quality of service. And those of us who design networks and work with networks know that it's a simple enough matter to provide a delineated quality of service in a local environment. But as you begin to peer across multiple networks, things frequently get lost in that process. And so I think one of the longer-term goals certainly would be to develop an overarching, ubiquitous quality of service designation for very, very important services such as telehealth, real-time patient monitoring, and so forth. And so this could be a very, very active area for research. And the other thing is that not everyone, especially in a rural area, is advantaged to have very, very expert network people on their staff. And in order to get differentiated service such as DiffServ type application, you have to have compliant applications. And I will just tell you at the outset that those are few and far between in the healthcare environment. So we have to build smart networks, networks that don't necessarily just know how to do an MPLS class of service designation, but can actually look at traffic streams, identify traffic streams that need high performance networking and high quality of service, and dynamically allocate that off. And we're just now beginning to see these kind of capabilities coming on stream from various commercial vendors. But an open systems approach or a more open-ended approach, I think, is clearly an area for very, very fruitful investigation. And wireless QoS. Wireless is going to be an important modality, particularly you'll hear some creative talks later today or reference to some new low-cost wireless long-distance modalities. Wireless is not a particularly friendly environment for quality of service, and I know there's a lot of fruitful research that could be done in that area. Path diversity. When we get into rural areas, path diversity is an important concern because of the fact that, unfortunately, primary connections aren't necessarily as reliable as they are in an urban area. So the whole idea of being able to use multiple modalities to interconnect these rural areas and do so in a way that will provide not only path diversity for primary link failure, but also in a very, very forward-thinking way, and some of you may be familiar with, for example, the performance routing capabilities, where the smart router looks at a particular data stream, realizes it's a video conferencing that needs a certain level of quality of service, and it can actually reroute that to an alternative network. So those kind of capabilities really, frankly, do not exist currently in the rural environment, and so that would be a very, very fruitful area for future research. And the other thing is, regardless of how much money the FCC gives us to pay for these network connections, ultimately they're going to have to pay for themselves. And it is a fact that network connections and circuits in rural areas are inherently more expensive than they are in urban areas. And so the whole concept of being able to develop dynamic bandwidth allocation, for example, if a particular application comes on stream, wouldn't it be great to be able to dynamically allocate a higher bandwidth for that application in real time? And so that is, again, another area I think where there's really fruitful areas for research. And I've already talked about optimizing multiple modalities. That is to say, you really want to look at the whole sort of panoply of applications or of network connectivities that are available and be able to make the best of all of them. And just very, very quickly, in 30 seconds or less, because I'm getting the nod from Javed, here are some areas that I see a very fruitful application of this forward-thinking network. Point-of-care devices, network-aware point-of-care devices. There's a great deal of effort involved right now in developing point-of-care testing, small, simple devices, but the quality, the quality of service and the ability to run those in an intelligent way really requires connection back to a mothership. And so point-of-care testing I see to be an important area of further investigation and integration into this network. Telepresence, and then one I want to leave you with, application virtualization. All major health systems like us are trying to develop a so-called electronic medical record. Okay? Well, that, in fact, is just really a software system that integrates multiple underlying software applications. Wouldn't it be great if we could virtualize that? In other words, the laboratory information system, the radiology information system, the radiology image store, be able to distribute that across a community or across an environment and virtualize that to such an extent that one institution doesn't have to buy the whole thing. So those are just some areas that I think we're going to be fruitful for collaboration and network development as we move ahead with the California Telehealth Network. Thank you. Oh, great. So we have 5 minutes for questions. Any questions now? Okay, Leslie.
Where is it that you're looking for type of collaboration with the California Telehealth Network?
Well, obviously, CITRIS would be an ideal venue to develop collaborations. There, for example, I don't believe our speaker will be available today, but the WILD technology, wireless long-distance wireless technology, could be an important adjunct to developing these collateral network connections that I'm talking about. And we're also very, very interested in the work that, for example, that Dr. Ben Yu is doing with high-speed wireless connections for mobile application, where, for example, wireless-equipped ambulances could have high-speed interconnection with a regional area to give patient information in real time. So those kind of applications, I think, are going to be extremely important. Yes? Yeah.
Just a quick question. When you're establishing all these telehealth connections, you're mentioning T1 lines.
Right.
How thought has been put into the explosion and the amount of bandwidth that's needed for the high
Yeah,
to be able to connect?
absolutely. And what we really tried to do was, the T1 is a minimum design point. For those institutions that have the capability of getting higher bandwidth connections, the network architecture is such that those can be transparently upgraded with no restructuring of the network. So if you have a DS3 connection, which is a much faster connection available in your area, that could be very transparently upgraded. But right now, what we're really dealing with is trying to develop a completely ubiquitous baseline technology across the entire state. And I know that doesn't sound like much, but when you get out into rural areas, it is a challenge even to get T1. There will be areas that get DS3s. There will be areas that even get higher bandwidth connections as the cost and the availability become reasonable.
Question over
Yes.
here.
I have a question. As a clinician that sees patients from different areas, one of the most frustrating problem for me is they come with a CD with outside films, and it does not necessarily. It's a very kind of sometimes a very difficult software to figure out. Here at UC Davis, we use what's called Stentor, and the other hospitals use totally different. Is there? I mean, this may not be relevant to what we're talking about right now. Is there a way to kind of have it so that a clinician can just not able to deal with all of that?
I think your question is one of the most relevant questions to what I was just talking about. The whole idea of an interoperable data milieu, what we really hope to accomplish here is to develop a seamless, interoperable network background. So folks sitting in Yreka, California, sitting in Eureka, sitting in Colusa, sitting in Southern California, say, I can click a button and I can connect to the Library of Congress, but I can't send my radiology result across town because of problems with image compatibility. I think we're going to see an upwelling of interest and really a demand from our clientele to really get in and solve these problems. It's not a technology issue. It's really a coordination and a focus issue. And so your point, actually the gentleman that's sitting down at the end of the table could probably tell us a whole bunch about that. But nonetheless, that will be, I think, a very fruitful area for the development of the RIOs and also for these virtualized systems that I was talking about.